inside your computer. You know it's something, don't you? Most of the time it does what you expect, but every once in a while you switch back to that tab. Say you're looking at you're playing your game, and your mom comes in, and you switch the tab real fast so that she won't see, but it takes too long. Or those updates, they come out of nowhere at the wrong time, and they put in a lot of weird files that have names like .dll and have dollar signs in them. So what on earth is going on in that computer? Fellow Toastmasters, those trenchant computer developers have made a nice, or they've tried to make a nice little environment for you, the end user. Your desktop is a nice little garden for you to go and look at your programs and open things and play with things. And once you get into your programs, they're built just for you. They've got psychologists to watch how you use the program so that they can make them work better for you. But beyond that, something happens in there. You know it's something. Well, what it is, there are actually some multiple layers in there. There's the part that you see on the outside of the onion. Then there are some layers in there of programs that help other programs and so forth. And right in the middle is, you guessed it, the kernel. The kernel basically runs the computer. You can think of it as the heart, or probably more accurately, the brain of the computer. What does it actually do? Well, the short answer is a lot. It would take, we would be here all night if I was to try to, heck, I don't even know everything that it does, and I'm a kernel developer. But to help you get a flavor of what it does, I'll talk about 3 different things. Device management controls all the different parts of your computer and helps them work together. Scheduling, it helps your computer do what it does smoothly through time. And virtual memory. You thought your computer really remembered you, didn't you? It only remembers you virtually. Let's start with the first one, device management. You all know what a device is on your computer, right? What would be an example of a computer device? Keyboard. Very good. Yes? Mouse? How about things that are inside the computer that you don't normally see? Things, the memory, yes, absolutely. Yes, and get the bus. All that has to play nicely together. And the pieces on their own don't know what they're doing. Back in the old days, those pieces used to talk to the computer by themselves. So you had a mail program. You wrote in your letter, you wrote in your email, you want to send it out. In the old days, it just bundled it up, sent it to the modem, and out into the world it went. And everything was fine. But then once we started getting more complicated computers that could pretend to run different programs at one time, now say you've also got your web browser, and one of those little tickers that goes across one of your web pages wants to reach out and call home and find out what letter to display next to the ticker. Well, they both send their packets out at the same time, and we get garbled. And this is just among programs that want to play nice, that don't intend to cause any problem. If you get a nasty program in there, if it's got free reign to your modem, that's, I mean, just hide like this, the torrent, the spam that's going to come out of there. So, this is part of what the kernel takes care of for us. The kernel plays traffic cop. It decides who gets to talk to the modem, when, and what it's allowed to send out over it. In fact, the kernel actually goes farther than that. It doesn't tell which programs that they can talk to the modem. It actually talks to the modem for them. Think about it. Do you know, does the program need to know whether it's talking to an old-fashioned modem or to an Ethernet card? Does it need to know how fast the Ethernet card goes? The kernel takes care of that. It'll bundle it up, and the program doesn't have to worry and just sends it off. Makes things a lot easier for the program and a lot easier for us. Now, while the kernel is playing traffic cop, what do we think of a traffic cop is doing? He stands at the intersection, right? Okay, you guys go for a while. Okay, now you stop. You guys do it for a while. Now you stop. That's what scheduling is. What is it, scheduling? Remember the old days when there's just one program. It runs from when you start it and it finishes, and you start another one. Nowadays, things are a little more complicated. You've got all these programs all trying to talk to the CPU at once. These days, we don't just have to make do with one CPU. We've got 4, maybe 2. But still, there are a lot more programs running than there are CPUs to handle it. So what do? They wait in line. It looks like they're all running at the same time because once they get their turn, it's not very long. Can you guess how long it might be?
Milliseconds.
You're close. 1/100th of a second. Sometimes it might take a little bit less because, say, the keyboard, say a word processor program is waiting on the keyboard. It's a lifetime in computer time waiting for, no matter how fast you type, from one letter to the next. So while your word processor is waiting for the keyboard, might as well let the music program play a little bit more music and then get back to the word processor when the keystroke comes back. To get an image of what this is like, picture a big sports field. Say that you want to have a baseball game, a soccer game, and an American football game all running at the same time on this field. It would be chaos, right? Well, say we start the baseball game. Baseball players come out, they throw the sandbags at the 4 bases, they cue up the first pitch, and then they play for 10 minutes, and then the whistle goes off. When the whistle goes off, at the end of the play, they pick up the sandbags, they run to the back, and out comes the soccer team. The soccer team puts up the goal nets, they play for 10 minutes, and then here comes the whistle. At the end of the play, they all go back in, and out comes the American football team. Once the baseball team gets back up there, they put the sandbags back out, they go to their original places where they were at the end of the play, and they start again. This is what's happening inside your computer 100 times every second. Kernel's got a big job, doesn't it? I'll tell you what is a really, really, really big job for the kernel is virtual memory. Now this is what it means for memory to be virtual. What does virtual mean to you? Anybody give me a good definition of virtual? Not physical. Excellent. Back in the old days, here we are again back in the 90s, programs directly talked to the memory. They had their chunk, and they did what they liked in it. But of course, remember what we talked earlier, all the many problems that can happen when you talk to the modem. It's even worse when all these programs try to talk to the memory at the same time. So here's where the virtual part comes in. We tell the programs that they have a chunk of memory, but it's really somewhere else. And when the program goes to look, the kernel really quickly diverts them to the right place. It's got a little table where it looks up what addresses the programs think they have and where they really are. This is good for a lot of reasons. For one, every program on your computer thinks it's the only one running. Gee, this piece of malware that I accidentally downloaded, I think I'll go and find the modem program and dump my spam out. It doesn't even know the program exists. It thinks it's the only one, which is really cool. Say, for instance, your memory is pretty full. You want to open a big program. To make room for it in memory, you close 4 or 5 little programs. Now your memory is in 4 or 5 chunks, none of which your big program will fit in. So what do? We use the chunks. We tell the program that it's all one big chunk, but actually those little arrows inside there just point to the various different little chunks. The programs are happy. We're happy. The kernel's happy. We use our memory a lot better. And another thing that we can do, we don't have to just rely on the memory. We can sneak some other devices in there. We can sneak a little sliver of your hard drive, even a file. Now those are a lot slower than normal memory. But the virtual memory part inside the kernel can treat those just like, very similarly at least, to real memory. something that you're not using and put it out to the warehouse, so to speak. Put it in the holding tank. And then once it needs it again, go get it. That's why that tab takes so darn long. You've been over here playing your games for a while. That's what's in the computer's foreground. That tab that you're going to use to hide it when your mom comes in, it's out in the warehouse. The computer goes to get it, swaps it back in, as we call it. That's what it's called, a swap. So if you've ever been looking around in your computer and you see something weird, this is what is actually being swapped. You can think of it as a warehouse is a good metaphor, or a holding tank is another good metaphor. If your computer is just bubbling with all this activity and is trying to cram so much into that memory, that's what it's doing. It's putting it out to the holding tank. So I hope this has given you at least a broad idea of what is going on in that deep inner sanctum memory. So next time you use your computer, don't panic when you see this weird stuff going on. The kernel can sometimes panic, but hopefully only us kernel developers see that. That's when we've made a mistake. Hopefully you won't see it. You'll stay in that nice, comfortable little place made for you. And when you're there, don't panic. The kernel is around. Thank you.